So today I'd like to show you guys one of my favorite integral tricks out there, namely the odd-even decomposition of the integral. And I'm gonna show it to you guys on the example of this beautiful integral from the natural log of 1/2 up to the natural log of 2 of the hyperbolic cosine of x divided by 1 plus 6 to the power of tangent of x. That's all with respect to x. So how are we supposed to solve this problem? First of all, I'd like to sit comfortably in my chair, finally, and then I'd like to call this integral some kind of I just to keep an eye on it whilst I'm evaluating it in the future. That was a joke, by the way. You laugh now, I hope. Anyway, now I'd like to kind of notice one more thing, which is that this lower bound here can be rewritten pretty interestingly in terms of, well, logarithms, I guess, because I can write it as just the negative natural log of 2 by the laws governing logarithms. We have this awesome logarithmic rule that the log base a of n b to the power of a c is equal to c multiplied by the log base a of a b. Yeah, awesome. And so we can just use it here because I'm just kind of raising a 2 to the power of a -1 inside of that logarithm. I can just take it out of the logarithm altogether. And now, what is the trick I want to show you guys? First of all, what we have to kind of notice is that this function here, the cosh? Hi Siri, how do you pronounce cosh of x?
I found this on the web for how do you
Bro.
pronounce Kosovo. Remember that. After you set up your contact information, in Siri settings, tap on my information and choose your name from the list.
And we will see that this guy right here is going to be an even function. Why is it so? Well, we know that the hyperbolic cosine of x is the same thing as e to the x plus e to the negative x all over 2. And so now we can just say that the hyperbolic cosine of negative x is going to be the same thing as e to the negative x plus e to the negative x all over 2. But this is the same thing as e to the x as just e to the x plus e to the negative x all over 2, which is, well, I made a cycle here, is just the hyperbolic cosine of x. So cosine is going to be an even function because it is just, symmetric with respect to the y-axis. Awesome. Yeah, but now we see one more thing. This tangent of x right over here, what kind of function is this going to be? This is going to be an odd function. Why is it so? We know that tangent of x is the same thing as just the sine of x divided by the cosine of x. But now, if I were to plug a negative x into this tangent, I'd get, well, sine of negative x all over the cosine of negative x, but this thing is just negative sine of x all over cosine of x, because sine is an odd function and cosine is an even function. And, well, what is this thing right here? This is just a negative tangent of x. So we get that the tangent of negative x is negative tangent of x. Well, this makes a tangent an odd function, and so 6 to the power of a tangent will also be an odd function. But how do I want to use it in our problem? Well, I'd like to propose to you guys a lovely u sub, which is going to look something like this. It's going to be a u equal to negative x. I'm just kind of flipping the sign of my x there, and this is going to make my du equal to negative dx. And as to the bounds of integration, whenever x is equal to negative natural log of 2, which is the lower bound, u is going to be the positive natural log of 2. And then whenever x is equal to the positive natural log of 2, the upper bound, u is going to be equal to the negative natural log of 2. And this is all the information I need to perform my u sub. And so it's going to make my integral I'm going to remind you, just the integral between the natural log of 2 positive up to negative natural log of 2 of the hyperbolic cosine of negative u all divided by 1 plus 6 to the power of tangent of negative u, and that's all negative du. But now I can use this negative in front of du in order to flip my bounds of integration. I can just make this negative sign a plus sign and negate this natural log there, and just kind of erase this guy. I don't really need it anymore. Yeah. And now one more thing, or actually two more things. We have this cosh of negative u, but because cosine, hyperbolic cosine, is just an even function as we've already discovered earlier, we get that this thing is gonna be the same as just the cosh of the u positive. Yeah, lovely. And at the same time, 1 plus 6 to the tangent of negative u, well, tangent of negative u, as we also checked earlier, is going to be just the negative tangent of the positive u. We can just rewrite this entire integral using what we just achieved. The integral between negative natural log of 2 up to natural log of 2 of the hyperbolic cosine of u divided by 1 plus 6 to the tangent, to the negative tangent of u du. But now, I don't really like this negative sign in front of the tangent in the 6th exponent, so I'd like to get rid of it. How do I do it? I can just multiply this entire integral by a 1. But not by any one, by a special kind of a one. I'd like to multiply it through by 6 to the power of positive tangent of u all over 6 to the power of positive tangent of u. Well, what was it gonna do with it? What is it gonna do to my integral? It's gonna just make it become the integral between natural log. What is it gonna do to my integral? It's gonna make it become the integral between negative natural log of 2 up to natural log of 2 of the hyperbolic cosine of u multiplied by 6 to the power of the tangent of u. That's going to be all divided by 1 plus 6 to the power of just the tangent of u. That's going to be all du. And now I'd like to perform the trick I was talking about at the very beginning, and so I'd like to add those integrals up together. I'd like to add this integral I've got right here to the integral in question that I had in the original problem statement. But I can't really do it right now because what I have here is an u. And there's another u, there's another u, there's another u. I am in the u world in this integral, once that integral up there was in the x world. So I can't really add them up together, but there is a solution to that, because those two integrals are definite integrals. Those two are just numbers. They are not antiderivatives. They are not gonna give me some other, class of functions or anything. These are just gonna give me numbers. And so there is no problem for me to just switch variables in them kind of to whatever I wish to. I could just, integrate this entire thing with respect to, some kind of a lambda, some kind of beta, alpha, theta, t, y, z, whatever I wish to. So I can just as well replace this u with an x, because this does not change the, final value of this entire integral at all. And now I'm ready to add those two integrals up. So I'd like to add myself the integral between negative natural log of 2 and natural log of 2 of the hyperbolic cosine of x divided by 1 plus 6 to the power of the tangent of x dx. And I'd like to add myself the integral between negative natural log of 2 and natural log of 2 of the hyperbolic cosine of x times 6 to the power of the tangent of x, all divided by 1 plus 6 to the power of the tangent of x dx. And one more important thing, both of those are equal to my I. Those are both equal. You're gonna just split me the exact same number. Awesome. So now I get that double my integral I is going to be equal to the integral between the negative natural log of 2 and the natural log of 2 of, I'm just gonna factor out the cosine of the hyperbolic cosine here. So cos x comes 1 plus 6 to the power of the tangent of x all over 1 plus 6 to the power of the tangent of x, and I think you already know why I performed all of those weird manipulations in the first place. Those two are gonna divide each other. Such a lovely thing to see, honestly. So what we're gonna be left with is just that, well, is just the integral between negative natural log of 2 and the natural log of 2 of the hyperbolic cosine of x. But the nice thing is that this is a symmetric interval, and cosine and hyperbolic cosine of x is even, so we can just kind of erase this natural log of 2, negative natural log of 2, and place a 2 in front of the integral, because the area under the curve in the positive direction and in the negative direction, they are just the same. But now what we can do is just definitely go on and cancel out those 2's in front. Let's maybe do something like this. I'm gonna cancel out those 2's in front of the I and in front of the integral. Now we get the only the integral we wanted to calculate in the first place. It's going to be the integral between 0 and natural log of 2 of the hyperbolic cosine of x, dx. But this is just the sinh, I guess, of x between 0 and the natural log of 2. But this is just e to the x minus e to the minus x all over 2 in between 0 and the natural log of 2. But that's just gonna give us, well, e to the natural log of 2 is just a 2 minus e to the minus log of 2, which is a half all over a 2, and then minus, well, this thing with x equal to 0 is gonna be just a 0, so we're gonna get 3 over 2, yes, that's gonna be 3 over 4. Hope you guys enjoyed it, and see you in the next one.